Hello, ladies and gentlemen. We're going to take a look at imaginary and complex numbers. So using I and understanding I. So in order to understand I a little bit better, there's two basic things we need to remember. First of all, that I is what allows us to deal with a negative square root. So I stands for the square root of -1. So anytime there's a negative sign inside of a square root, we know that we're probably going to put an I in our answer, right? That's what that value means. Now also, if we were to square I, if we had I squared, that is not imaginary anymore. Because if I squared both sides of this, I squared, and then I'd have the square root of -1 squared, I squared would just equal -1. So we have one part, I, representing the imaginary number coming from the square root of -1. The other major fact is that I squared equals a regular -1. So let's take a look at how that comes into play. First of all, in our process of solving, sometimes we get negative square roots. And so in order to simplify them, we need to understand that that's going to lead me to an imaginary answer, one that really doesn't exist. So we need to be able to simplify the square roots of negative answers, right? But we need to do so using the I, the imaginary unit, okay? So square root -56. If I was going to simplify that, I might first start by recognizing that this problem is going to have an I. So I might think about this as the square root of -1 times the square root of +56. Now remember that square root of -1, that's just I, right? So all we're saying right now is that the part of our answer definitely is going to have an I. So if we were to think about this, we'd have the I square root of 56, right? But that square root of 56 can be broken apart some more. So we need to think about what perfect square can I divide out of the number 56. So I might try a few. Does 56 divide by 9? No. Does 56 divide by 16? No. Does 56 divide by 25? No. I try to divide perfect squares out of the number 56 until I find one that works. One perfect square that divides out of 56 is 4. 4 times 14 is what made the square root of 56. But the square root of 4 is just 2. The square root of 14 is going to stay the square root of 14. Now remember, there was an I here, right? So I need to remember to place that I in my answer. It would be written as 2I square root of 14. Okay, so simplifying using the imaginary number when we need to put it in there, we're going to look for that when we have a negative square root. Now, if I already have a problem with an I in it, we need to remember and understand like terms, the distributive property, all the things that we do with x's, we need to remember to do with i's. So here, these two sets of parentheses represent complex numbers. There's a nice real number part and there's an imaginary number part. There's a real number part and an imaginary number part. Now, if I were going to add these, I would just need to add like terms. But here, there's a times sign that we need to read in between those sets of parentheses. So in order to multiply, I need to use the distributive property. And I need to do so multiple times here because I have 2 things times 2 things. So I'm going to take 6 times 3, making me 18. I'm also going to take the 6 times the negative I, making -6I. Then I'm going to take the I times 3, making 3I. 1I times a negative I makes a -1I squared. Anytime there's an I times an I, we're going to need to have an I squared. Now, if I take a look at what we have here, I have 18. I'm going to go ahead and combine these two because they're like terms. That's -3i's and minus an I squared. Now remember, I squared stands for the number -1. So this thing right here is like a -1. So I have -1. That's like adding. So I have 18 minus 3i plus 1. Now, because I turned my I squared into that regular number now, right, that real number, I can go ahead and say, hey, I have 18 and a +1. I can combine those two together, making 19 minus 3i. So 19 represents the real part, and then the negative 3i represents the imaginary part, okay? So dealing with these i's, a lot of it, same skills that we would normally deal with in x. We just need to remember that I squared equals negative 1, and that the imaginary number I comes into play when we have square root signs and negatives inside that value, okay? So I want to thank you again. I'll see you later, Sabers. Kincaid out.